In this video, we are working with understanding the multiple linear regression. When you want to estimate the one dependent variable with a non-independent variable, this process in statistics is called as regression. When value of the dependent variable is estimated by only one explanatory variable, this is a kind of simple regression. But the value of dependent variable is estimated by more than one explanatory variable. This comes in the terminology of the multiple regression. For example, we want to study the mortality rate, uh, which is our dependent variable, with respect to age in years. So when the mortality rate is estimated by the age in years, this is a kind of simple regression. But if we want to add the effect of other than the dietary score, so dependent variable is mortality rate, and our independent variables are age and the dietary score. So such kind of regression is called multiple regression. And the model for the multiple regression is like that. Y is equal to beta naught plus b1 x1 b2 x2. This terminology add up until we add that much regressor. And the model for the sample is y hat is equal to b naught plus b1 x1 plus b2 x2 if we have only two variable, plus the error term because we are not encountering all the effect of all the variable which are affecting the dependent variable. To understand more, we are working with real life data 195.sav, which is available on the internet, and we are going to use in the SPSS example. From that data, we are going to take a dependent variable, which is average female life expectancy, and the independent variable daily calorie intake, and the people who read, which is implying as a literacy rate. Using the conventional regression methods, using SPSS, we will use analyze, regression, and the linear in SPSS. We will put the average female life expectancy into dependent box and the calorie intake and the people who read in the independent box. And pressing the OK to study the effect of the calorie intake and the people who read on the female life expectancy. The regression output contains mainly the three tables. This is the coefficient table, which actually give us the B naught and B1 value. The constant term is the B naught, and the values corresponding to the variable we have chosen are B1 and B2. The main concern is that how to interpret these values. The constant is estimated as the coefficient of the literacy rate, which is 0.315. It is estimated as that with the increase of the 1% literacy rate, which is the people who read, the female life expectancy increase up to 0.315 unit, provided that the effect of calorie intake is holded, or it was kept constant. While holding the effect of the literacy rate, which is people who read, the female life expectancy increase up to 0.007 years when we consider the effect of the calorie intake. And the standardized coefficient, we can also compare that the people who read have the more effect as compared to the calorie intake. Similarly, to interpret the constant, we will say that the holding the effect of calorie intake in the people who read, the average female life expectancy is 25.8 years. Then we have the another table, which is the model summary, which actually depicts the R and the R square. The R is our correlation, and the R square is the coefficient of determination. The correlation coefficient in multiple regression is actually depicting that the female life expectancy is highly correlated with the two predictors, which were calorie intake and the people who read. While the R square, which is the coefficient determination, it is telling us that the proportion of variation in female life expectancy explained by the two predictors, which are calorie intake and the people who read, that is 81.8% of the variation is explained by the two variable, while the remaining 18% approximately is not explained by the two predictors. And we have the third table, which is the ANOVA table. ANOVA table depicts the effect of all the predictors in the model simultaneously. So this is the p-value is produced by the F statistics in ANOVA, which is less than 0.001. It implies that both the predictors, which were calorie intake and the people who read, had both predictor has simultaneously a significant effect on the female life expectancy. This was the cover in the video. The rest of the lecture is going to in the next lecture.